Here is a picture of the inside of a house that has, of course, circuits in it. And architectural wiring drawings are the one kind of electrical drawing that we will not be studying in this class. The reason is that we look at electrical wiring in the architectural plans class. Nevertheless, circuits are universal in electrical stuff. And so I want to think just briefly about circuits, and this one will be real short. The main idea we want to get hold of is that a circuit is a closed loop of conductors which form a complete path. And you need to have a closed loop in order for current to flow. In a circuit, you have some kind of voltage source, could be a battery and a flashlight, and you have some kind of load. Load could be the bulb. So here on the left is a sort of a pictorial drawing of a battery and a lamp. The drawing on the right is a schematic showing the schematic symbol for a battery and the schematic symbol for a light bulb. So this is a schematic drawing of a flashlight minus the switch. So here's the voltage source, the battery. Here's the path for the current to flow. And here is the load. The load is the thing that is using the electricity. And in the case of a flashlight, that's a light bulb. A circuit, like a flashlight, can also have a control device. So in this schematic in the middle of the slide, here is a flashlight with a switch added, and that's the control device. And you can see when the switch is closed, that line, that path that the electrons flow along, is a closed line, so the electrons have a place to go. In the bottom, we see the switch open, which means the electrons can't get from the battery to the bulb. That switch is open, so no current will flow. And then circuits usually have other stuff too. They've got wires or conductors. The wires have insulation on them. In addition to the load, like the light bulb or the stove, and the control device, like the switch, there's often some kind of protection device, a fuse or a circuit breaker, for example. And when we get to motor control circuits in a few weeks, we'll look at those protection devices a little bit. Then the last three slides, 4 slides, are just more in case you're interested. We're not going to talk about these in our quiz. Just know that there are 2 ways that one could connect a bunch of loads to a voltage source. You can connect them in series, which is what you see in the top picture, or you can connect them in parallel, which is what you see in the bottom picture. Now, you might be familiar with this idea if you've ever messed around with holiday lights, like you're going to put on a tree or put on an outside of a house. In the olden days, those holiday light strings would be wired in series, and if one of the little bulbs burned out, the whole string went dark. Then people figured out, hey, we should wire these in parallel. So they did, and now if one bulb goes out, the rest of them stay lit. This is out of a kid's book, by the way. I really like kids' books because they strive to explain ideas so that a kid could understand them, which means somebody like me has a chance of understanding them, or somebody like you. I like them for their simplicity and clarity. Anyhow, here are some pictures of a series and a parallel circuit out of a kid's book. And these are drawings, as you can see, of a circuit board with resistors on them, series and parallel. And then basic principles that electrical designers use when they're thinking about how are these circuit's going to work. So I leave these here for your reference. If you would like to come back and study electrical theory or electronic design at some point, this will be a good starting point, thinking about what happens to the current, the voltage, and the resistance if they're wired in series or if they're wired in parallel. That's the last we're going to say about that.